Hi, welcome to Dr. Vasu's lectures. In this, I'm going to present you a magic square. A magic square is it's a square having odd number of rows and odd number of columns. It can be a 3 by 3 or 5 by 5, 7 by 7, any size of the matrix. The special with this magic square is here if you take any row like this, any row, the sum of the elements, sum of all these elements, or if you take any column, sum of any column here, or if you take any diagonal, this diagonal or this diagonal, all these elements is equal to the same number. That is the special about this magic square. Here I am going to present you, give you a trick which you can fill this entire magic square, a 5 by 5 magic square in just 1 minute. Are you not believing? Just look at this. So a magic square is one which is having sum of all the elements in any row or column or diagonal must be the same sum of all these elements. That is the rule. Now we are going to see a magic square, how it will be filled. Suppose I have taken a 3 by 3, right? A 3 by 3 square. I start with the right side, rightmost, the middle cell here, right? Out of these three, I have taken the middle cell. I start with 1. Okay. Now, because here I have all 9 squares, 9 small squares, I have to fill this with 1 to 9, starting from 1 to 9. Now, no number should be repeated, and the sum of these elements in this first row, or the second row, or the third row, or the sum of the elements in the first column, second column, third column, and the diagonal elements here, this diagonal or this diagonal must be same. Let us see how much it will be. Okay. Now, so we have started with the middle cell in the rightmost side. Okay. 1. Next, 2 should be filled. The 2 should be filled in a diagonal cell like this. To this, you go towards right side and take a cell right side. So here, if an imaginary row and columns are filled here, I imagine this as a 4 by 4 square. So for this, the right side diagonal corner is this. Because this is an imaginary element, the imaginary table, I have to fill this, only this table, right? These 9 cells. When you have come out of this cell, come to the right side, whatever is there here, it will be filled in the first column. Okay. Suppose if you have come to the top, then here we don't have a square. This is only an just imaginary. For your understanding, I have just given the square, right? So if you come to the top, then come down and fill this one. Let us see. I have, for this one, the diagonal element is 2. 2 should be filled here. Because we don't have this, I come to the leftmost side and fill 2 here. Okay. Now, for each element, you go to the corner, right top corner. Okay, right side top corner. For this, the right side top corner is this one. So 3 should come here. Because we don't have the cell here, you come down to the bottommost. So fill 3 here. Now, here comes the one interesting aspect. For this 3, we have an element, you have to fill 4 here, right? But already this element is filled. Okay, this cell is filled. So what we do is come down from this cell, come down by 1 row and get back to the left side by 2 elements. I'm here, next and next. Just pick an alternative cell, just not the adjacent, just an alternative cell, and fill 4 here. 4. Next, after this 4, for this cell, the right top corner will be this. So 5 comes here. Next, for this, the next top corner is this one. So 6. For this, again, 7 will be the right top corner. But here, we don't have the cell. So what do? We have to come down by, for this cell, the right leftmost corner is this. Okay, because we don't have this cell, I have to come to the leftmost side. And here, again, we don't have a cell here in the top. So you have to come down. But this cell is already filled. So what do? Take the cell. For this, the diagonal cell is right side top corner. This says, come down by one cell and take an alternative one. That is, for this one, the one cell down and 2 cells to the left. That is 7. So 7 comes here. That's how. Next, for this, the right top corner is this one. So 8 should come here. Because we don't have this cell, you come down and fill this cell with 8. For this, the right top corner will be, the diagonal corner will be this. Because we don't have this cell, you come to the left side and fill this with 9. So all the cells are filled here. So this is the magic square. So we have taken all the numbers starting from 1 to 9, no repetition, and all the numbers are filled, all the cells are filled. Now if you sum up all the elements in any row, first row, 2 plus 7 plus 6, how much? 15. Similarly, second row, 9 plus 5 plus 1, 15 again. Next, third row, 4 plus 3 plus 8, 15. Next, 2 plus 9 plus 4, first column, again 15. 7 plus 5 plus 3, 15. 6 plus 1 plus 8, 15. Right? So, here, we take the diagonal. Right? Diagonal is 2 plus 5 plus 8. That is 15 again. Right? Next, another diagonal, 4 plus 5 plus 6. Again 15. So that's it. If you see any of the sum of all the elements in any row, any column, or any diagonal is 15. So this is the magic square 3 by 3. Next, let us see a 5 by 5 magic square. How it is filled. So what is the first rule? First rule is you have to start with the rightmost middle cell, rightmost middle, right? 1, 2, 3, 4, 5. Middle is this. So I start with 1 here, right? 1. For this, I'm not drawing any imaginary squares here. So for 1, the diagonal will be, right top diagonal is this. Because we don't have a cell, you come to the left side, fill this cell with 2. For this, the right top corner, 3. For this, next right top corner will be coming here, but we don't have cell. So come to the bottommost, right? So for 3, the next will be 4. It comes here. Next, 5, diagonal, 5. For this diagonal cell is 1, but it is already filled. So what do? From this cell, you come down by one number and take an alternative number here, alternative cell. So 1 down minus 2, that is 6 comes here. Clear? Next, for this, the diagonal 7. For this, the diagonal 8. For this, the diagonal will be here, but we don't have a cell. So what do? We come to the leftmost position and fill this cell with 9. Next, from here, you go to next diagonal cell will be coming here, but we don't have a cell. So come down, bottommost cell. This is 10. So 10 is filled. For this, the next diagonal is this one, but it is already filled. So what do we do? From here, you go down by one cell and minus 2 cells, right? Not the adjacent, but the next one. So for after 10, the 11 number will be coming 1 down, minus 2, here 11. Next, for this the diagonal corner 12, for this the diagonal corner 13, another diagonal corner 14, diagonal corner here 15, diagonal corner for this will be coming here, right? But we don't have it. But for this diagonal, generally the diagonal will be coming here. Clear? So even if you take for this one, the leftmost side will be this. Because we don't have a cell, you have to come down like that. So for any cell, a diagonal cell here will be next will be this one, corresponding cell. But it is already filled. So what do we do? From here, we go to the corner, diagonal cell, come down by one cell and minus 2. That is 16 comes here. Okay. Next, 16 after this 17. The diagonal. The diagonal comes here, but we don't have cell. Come down to the bottom. 17 comes here. Okay. After 17, you come to the 18. This diagonal. But we don't have a cell. What do? We go to the leftmost position. 18 comes here. Next, 19, 20. After 20, another diagonal is here. 21 should come here, but it is already filled. So come down by 1, minus 2. That is 21 comes here. 21. From here, the diagonal 22. From here, the diagonal 23. But we don't have a cell. Come down. 23. For this, the diagonal 24. For this, the diagonal will be coming here. Because we don't have a cell, go to the leftmost cell, 25. Great. We have filled all the cells starting from 1 to 25, 5 by 5 matrix. So altogether we have 25 numbers. All the cells are filled with from 1 to 25. And now the interesting part is, if you sum up all these elements, it sums up to 65. You take the second row, 65, third row, again 65, fourth row, 65, fifth row, 65, first column, 65, second column, again 65, third column, 65, fourth, everything. All the columns, all the rows are 65 each. Next comes the diagonal elements, 65 again. This diagonal, and here it is again 65. Oh God, we have filled all the cells, and because I am giving you the explanation, it took a longer time. But when you come to when you understand this principle, this trick, and if you start filling it up, just you can fill it in 1 minute. Are you ready? Just try it. You get a magic square 5 by 5 in no minute, in no time, just 1 minute. All the best. Go ahead. Subscribe to Dr. Vasu's lectures. If you like it, I'll come up with another Vedic mathematic principles. Thank you.